Hello, everybody. I wanted to do a quick review of question 7b from page 24 in the chapter 9 packet. This is from last Wednesday's assignment. So here we have the absolute value of x plus 1 is less than 6. The first thing that I'm going to do is I'm going to change this to an equal sign. And then I'm going to solve for x, and the absolute value is already isolated. There's nothing else over on this side of the equation other than the absolute value, so we call that isolated. Once the absolute value is isolated, we're going to solve this twice. Once when x plus 1 equals positive 6, because if this were a positive 6, the absolute value of 6 is 6. And another time when x plus 1 is equal to negative 6, because if this were a negative 6 inside of here, the absolute value of negative 6 is 6. So either one of those solutions would work inside of that absolute value. So in order to make this a 6, x would have to be a 5. And in order to make this a negative 6, x would have to be a negative 7. And I've made a lot of comments on some of your assignments that you really have to pay attention to these details with the negative. So be careful with that. So if this were an equation, we'd be done. But this was not an equation. This was an inequality. So what I have to do now is I have to take the negative 7 and put it on a number line, and take the 5 and put it on a number line, and those are my boundaries. I'm using an open circle because the original inequality did not have a line in it. And so the answers are either here or here or here, in between the two boundaries or outside the two boundaries. And what we're looking for is numbers that make this inequality true. So 5, if I plug it in, does not make it less than 6. It makes it exactly 6. So I want all the numbers I can plug in for x that give me an answer that is less than 6. If I plug in a 4 right here, I get 4 plus 1 is 5. 5 is less than 6. That means 4 is an answer. If I plug in 0 right here, I get 0 plus 1 is 1. Absolute value of 1 is 1. 1 is less than 6. That means 0 is an answer. So I accidentally just tried 4, which is right here on the number line, and I tried 0, which is right here on the number line. And I'll try negative 1 just for the sake of you seeing me actually plug in a value for x. And when I plug in negative 1, I get the absolute value of 0, which is 0 is less than 6. That is a true statement, which means that negative 1 is also a solution. So this was a solution, this was a solution, and this was a solution. So all of my solutions are between negative 7 and 5. A lot of students are just keeping the sign the way that it is, and if you do that, you end up saying that the answers are less than negative 7. But let's just pick a number less than negative 7, like negative 10. If I try negative 10, I get negative 10 plus 1. Absolute value of that is less than 6. That's negative 9. Absolute value of negative 9 is less than 6. That means 9 is less than 6, which is not true. It's a good thing we tested these values so that we know that our final answer is x is greater than negative 7, but less than 5. And that's how we write our final answer. Please make sure you're using test values. These inequality symbols will flip quite often, and there are a lot of rules to determine when they do and do not flip. To avoid memorizing all those rules, we're just testing different values, and then we know where the solutions are without having to know all the rules. Have a good day.